All right, today we're going to do Chapter 5, Section 3, Part 1. So these notes are split up into two different sections. So all of these notes, so these 9 pages we're going to do today, there's going to be a separate note, a separate PDF for Part 2. We're going to be solving polynomials by factoring. So we've already factored before, so we're kind of just continuing with what we already know. I'm going to change this equation, this first one that it gave us. You can cross it all out. I'm changing the whole example. So cross it all out and make it x cubed. That is supposed to be a 3. X cubed minus x squared is equal to 30x. So I'm just changing the whole example. Make our lives a little bit easier. Okay, to factor. How do I start? What should I do first? Remember, I want it to be equal to 0. So how do I get that equal to 0?
Subtract 30x.
Subtract 30x on both sides. So I have x cubed minus x squared minus 30x is equal to 0. So now I got that equal to 0, so I can start factoring. Before I even factor though, do I have a greatest common factor that I could take out here? Do any of these 3 terms have something in common? They all have an x. So I want to take out an x from all 3 of them. So if I take out an x, what am I left with?
But 2 have different exponents together. Does that matter?
So this just says that it has 3 x's here. This one has 2 x's. This one has 1 x. So all of them have at least 1 x, so I can take out an x. So if the first one has 3 x's, how many x's am I left with if I take one away? 2. So I have x squared. What would be next? Just x. And then what's last? Minus 30. And now I want to factor what's inside the parentheses. So remember, to factor, we need to think, what are 2 factors of negative 30 that add to negative 1? What are 2? What'd you say? So 2 numbers that multiply to negative 30 and add to negative 1. Negative 6 and 5. Awesome. Because negative 6 times 5 would be negative 30. Negative 6 plus 5 is negative 1. Perfect. So we have x times, my pencil's not working, there we go. Remember, after we factor, we put it into our parentheses. So we have x minus 6 and x plus 5. And the reason why it's minus 6 is because this was a negative 6 and this was a positive 5, so that's why it's x plus 5. This is equal to 0. So we have 3 little pieces here. We have x minus 6, x plus 5. What do we do next to solve for x? Split them all up. So we have x is equal to 0, x minus 6 is equal to 0, and x plus 5 is equal to 0. So x is equal to 0, done. Already solved for us. We don't have to do anything else there. How do we solve for x in the next one? Awesome. Add 6. So since it's x minus 6, we do the opposite. So we add 6 on both sides. So we have x is equal to 6. So that's our second answer. And then in our third equation, how do we solve for x? Subtract 5. So x is equal to what? Negative 5. Perfect. So those are our 3 answers for x. A little hint, we started with x cubed. So we're going to have 3 answers for x. So since we started with our highest degree on that x was 3, we get 3 answers. So it's just a little hint to tell us how many answers we'll get at the end of our problem. Alright, next. So again, we're solving by factoring. Do we have any greatest common factors that we can take out to start? An x, anything else? 2x. So we see all of our numbers have a 2 in common and all of our terms have an x in common. So we can take out a 2x. So the different exponents just, again, it's saying that this has 3 x's here. So we could take out an x because there's 3. This one has 2 x's, so we can take out an x because there's 2. This one just has 1 x. We can take out an x because there's 1. So all of them have at least 1 x in common. That's why we can take out an x. And then if we look at the numbers, all of them are divisible by 2, so we can take out a 2 also. We always want to start with x squared. So anytime we're factoring, we want our first term here to be x squared. It's just going to make factoring so much easier for us. So if you ever see that we have an x cubed to start, 99% of the time you want to take out an x. So we're left with x squared as our first term. What comes next? If we divide this by 2x, what are we left with? Just x, so plus x. And then we're dividing this by 2x, so what are we left with here? Minus 2. Perfect. That's equal to 0.
Ms. Carr,
Yes.
just to clarify, you took the x squared because we started with x3, right?
We started with x3, and I took out 2x. So if I have 3 x's and I took 1 away, then I'm left with 2 x's. So that's where I got this x squared.
All right, thank you.
Good question. All right, now we can factor. So do I have 2 factors of negative 2 that add to positive 1? Two and what? 2 and negative 1. Perfect. 2 times negative 1 is negative 2. 2 minus 1 is positive 1. Awesome, that works. So I have that 2x that just stays out front. What goes into my parentheses now? X plus 2 and x minus 1. How do I solve for x from here? Split it. So 2x is equal to 0, x plus 2 is equal to 0, and x minus 1 is equal to 0. So I just split each piece up. So I have one piece here, another piece here, and another piece here. I split each piece up and set it equal to 0. So now I need to solve for x. In my first equation, how do I solve for x here? 2x is equal to 0. How do I get that x all by itself? Awesome. Since 2 is being multiplied to x, we do the opposite. So we divide both sides by 2. So we get x is equal to, what's 0 divided by 2? 0. X is equal to 0. So that's answer number 1. Now let's move on to our second equation. How do I solve for x? Perfect. Since 2 is being added to x, to get rid of it, we subtract 2. So x is equal to what? Negative 2. Awesome. So that's our second answer. And then our third equation, what do? Add 1. Since 1 is being subtracted, we do the opposite, so we add 1. So what's x equal to? Positive 1. So that's our third answer. So if we see, we started with x cubed. That tells us that we have 3 answers. Here we have 1, 2, 3. 3 answers. So we are factoring a sum or difference of cubes. So this is our sum of cubes equation, and then this one's our difference of cubes equation. So anytime we are adding 2 perfect cubes, we can factor it into this. So we just have to find what our A and our B are, and we just plug it into this equation. So you guys can use your notes on the next test. So you'll have this equation in front of you. So we just have to find what A and B are, and then we plug it in. So A is going to be a perfect cube, and B is going to be a perfect cube. That means the same number multiplied by itself 3 times is going to be that number, A or B. And then if we're subtracting, so difference means subtract. So if we're subtracting them, we use this formula. So it's the same thing, but the signs are a little bit different. On this slide, we have our common cubes. These are some numbers that we'll see pretty often. So if our equation was, let's say, 8, my pencil is still not writing. Let's say it was 8 plus 125. So 8 is our A cubed. A cubed is equal to 8. What would our A be? What number cubed gives us 8? 2. So A would just be 2. And then if B cubed is 125, what would just B be? 5. Awesome, because 5 cubed gives us 125. So these are some common cubes we're going to see. And then there'll also be like an x cubed too. So if this was 8x cubed, our A would be 2x. So if there's an x there, we just have to put that in our A or B, wherever it is. So let's do some examples. So here we have the sum of cubes. Our sum of cubes formula, I'm going to write it up top here, is A plus B times A squared minus AB plus B squared. So we have to figure out what our A and what our B are and just plug it into this formula. So if our A cubed is x cubed, so that's just our first term is our A cubed, then what is our A? What's A? 1x, or just x. And then if our B cubed is 64, what is our B? What number cubed gives us 64? Go back to that common cube slide. 4. Careful, because 64 is 8 squared, but we're dealing with cubes now. So it's like 8 times 8 times 8 would be way too big. But 4 times 4 times 4 is 64. So that works. So now we just take our A and B and plug them in. So we have A plus B, so x plus 4. And then A squared. So what would our A squared be? How do we write that? If our A is x. Perfect, just x squared. And then minus A times B, how would we write that? 4x. Awesome. And then plus B squared. How do we write our B squared if our B is 4? 4 to the second power, but what is 4 to the second power? 16. 4 times 4, which is 16. So this is our answer. So all we need to do is find what our A is, what our B is, and then just plug it in to our formula up here. No, this is as factored as it can be. We don't have two factors of 16 that add to -4, so we can't factor it anymore. Okay. So just like factoring before, again, we need this to be equal to 0. So it's equal to 0, so you can go ahead and start. We need to figure out what our a is and what our b is. So if our a cubed is x cubed, then what's a? X. Awesome. If b cubed is 8, then what's our b? 2. Perfect. If we go to that common cubes, if we see 8, that is 2 cubed. So now we plug it into our equation. So we have a plus b. So that would just be x plus 2. Then we have a squared. How would we write a squared? Awesome, just x squared. Then we have minus a times b. So what would a times b be? 2x. And then plus b squared. What's b squared? 2 to the second power. So what's 2 to the second power? 4. Perfect. Good job. So this is our answer here. All right, next. Here we have a difference of cubes. We can't see it yet because we don't have equal to 0. How do we get this to be equal to 0? Awesome, subtract 1. So we have 8x cubed minus 1 is equal to 0. Perfect. So now we just need to figure out what our a is. So if a cubed is 8x cubed, what's our a? 2, but 2x. Awesome. Since we still have that x cubed, we need that x there. So can't forget about that x. And now our b is b cubed is 1. So what's our b? 1. We don't keep the negative when we have our b just because it's the difference of cubes, so we're subtracting anyway. So we just use that second formula that we have. So our formula starts now with a minus b. So how would we write a minus b? For difference of cubes, it's subtracting. So you have to look at the second formula on that page. Awesome, 2x minus 1. So just remember, the formula for difference of cubes when you're subtracting your cubes is different than when you're adding them. It's the same formula, just the signs are different. So you got to be careful with the signs. Next, we have a squared. So how do we write a squared? 2x squared. But the 2 is also being squared. So what's 2 squared? 4x squared. So this is 2x squared. We have to distribute that squared to the 2 and to the x. So it is 4x squared. Next, we have plus a times b. So what's a times b? 2x. And then plus b squared. What's b squared? 1. So this is our answer. Last one. So again, difference of cubes, so we use that second formula on that page. So if a cubed is x cubed, then what is a? A is x. And then 27 is b cubed. So what is b? Go back to your difference of cubes page. What would give us 27? 3. So now we just have to plug it in. So we start with a minus b. So how would we write a minus b? X minus 3. And then we multiply that times a squared. So how would we write our a squared? X squared. And then we have a times b. How would we write that? 3x, perfect. And then plus b squared. How would we do our b squared? 9. Awesome. Good job, guys. You did really well today.